Hello, everybody. Mr. B here again with our fraction series of videos. This is video 3 about prime numbers and prime factorization. We're going to step away from talking about fractions directly, and the next few videos are going to be about topics that are related to fractions in some way. So we'll see how it's related later, how they're related. First of all, what's a prime number? A prime number is a number that's divisible or can be divided evenly only by itself in 1. So let's list the prime numbers. And we don't include 1. I know 1 is divisible by itself in 1, but we don't include 1. We start at 2. So 2 and 3 and 5 and 7, 11, 13, I think 17 is the next one, 23. Dot, dot, dot. There's an infinite number of prime numbers. So if I choose one of these numbers, like 7, that's divisible only by 7 and 1. And same with all these other numbers. So if a number isn't prime, we call that number a composite number. And composite numbers can be written as the product, the multiplication of prime numbers. So how about 6? 6 can be written as 2 times 3. Those are prime numbers, right? So 6 is divisible by itself in 1, but also by 2 and 3. This 2 times 3 is the prime factorization of 6. So how do we easily find these prime factorizations when the numbers are like bigger than 6? There's several ways. The way I like to do it is with something called a factor tree. Here, we'll do a factor tree for a number like 6. So you write the number that you want to get the prime factorization for and write some branches under it. And then I usually jot down a few primes and start with the smallest prime and ask the question, does 2 divide into 6 evenly? And it does. 6 is even. 2 goes into 6, 3. So you can see on the end of these branches here, these two numbers multiply to be the number above, 2 times 3. And notice that those branches now reach just to prime numbers. We're done when the branches end with prime numbers. So that's how we know that 6 is 2 times 3. All right, let's do this with a bigger number so we don't have just one layer, about 140. So again, jot down some prime numbers, the small ones. You write down as many as you need as you go on. But you always start, if you do this systematically, start at 2. Since the number's even, we know 2 is going to divide in. 2 goes into 140 70 times, and 2 times 70 is the number above, right? You can see how this works. All right, now we look at that right number, and that's a composite number. That's not a prime number. So does 2 still divide into that? You keep going with a prime number until you've sort of exhausted all of the ways it'll divide in. Okay, so 2 goes into 70. 70 is even 35 times. So we're done with 2 because 35 is not even. What's the next that'll divide in? Does 3 go into 35? We'll see the divisibility rule for 3 is if you add the numbers, if that sum is divisible by 3, then it's divisible. The big number is divisible by 3. But 3 doesn't go into 8, so 3 isn't going to work. How about 5? Definitely. The number ends in 5, so it's divisible by 5. It goes in 7 times. So now we see at the ends of the branches, we have nothing but primes. We're done. The prime factorization for 140 is 2 times 2 times 5 times 7. So there's our prime factorization. Pretty easy. Let's do yet a bigger number than 140, just to see how well this works. 1188. And you can use a calculator to do some of this division when you're doing the tree. Okay, so let's jot down some primes here. We may not need them all, but we'll see. All right, so the starting number is even. We know 2 will divide in. And I'm going to look at my notes here so I don't have to get the calculator out and do long division right now. So you get 594 here. Okay, so now we look at 594. Is that still divisible by 2? Yeah, it's even. And if you divide that by 2, you get 297. Okay, so we're done with 2. The number's no longer, on the right is no longer even, so the question is, does 3 divide in? Divisibility says if we add the numbers, we get 18. That's divisible by 3. So this number is divisible by 3. If you do that, divide by 3, you get 99. That's still divisible by 3. And it goes in 33 times. It's still divisible by 3. Okay, and then we get 11. And now we're done. All the branches lead to prime numbers. So we see that the prime factorization for 1188 is 2 times 2 times 3 3s and an 11. You can see how easy this is, right? So use a factor tree to get the prime factorization of numbers. We'll see why we want to do that later. Just a quick word about divisibility. If you're doing this by hand, it's kind of nice to know the divisibility rules. A number is divisible by 2 if it's an even number. So 24, that's an even number. If you divide by 2, you get a number that has no remainder. It divides in evenly. Divisibility by 3. If the sum of the digits is divisible by 3, then the number is divisible by 3. So 144, notice this is, if we add up the digits, we get 9. That's divisible by 3. And so 144 is apparently divisible by 3. I'm going to do that on my calculator real quick. You get 48. It divides in evenly without a remainder. How about this big number? Let's add up the numbers, the digits. 6 plus 3 plus 2 plus 9 plus 7. Let's see, that's 9, 18, no, 9, 11, 27. 27. That's, you know, if you're kind of wondering, does this number divide by 3? Well, add those up and you get 9. That's divisible by 3. So this must be divisible by 3. So this must be divisible by 3. And if you do that, what do you get? Let's see, 63297 divided by 3. It goes in evenly, 21,099. So this divisibility stuff can be helpful for doing factor trees. Okay, folks, that's it for this video. We'll see you for the next one.